Welcome to the factory of programming. Prepare your mind for exclusive tech experience. Listening to Vivo Bon right now.
Hello, today we'll see a presentation about virtual threads, the lightweight concurrency for everyone. So let's begin. So first, what is the problem that solve virtual threads? Virtual threads because before we have traditional threads, but traditional threads has some issues. This was threads that was linked to OS threads. I mean, there were OS threads. There was no two kind. There was only one kind of thread that you can use easily, and that was operating system thread with a one-to-one mapping. And these operating system threads were expensive in memory and in context switching. So the thread per request style was simple, but it didn't scale. So the result was that the throughput was capped by OS thread limits. I mean, the threads were the bottleneck. You can't have more than you want because there was a limited number of operating system threads. So there were solutions that have been developed. For example, Async and Reactive programming. It was interesting because it was non-blocking APIs with callbacks like CompletableFuture and Reactive framework, like Spring Reactor with Webflow, Mono, etc. There was better scalability, but it was harder to read. No loops, try catch, debugging and profiling was painful, and stack trace lose meaning. I don't know if you have ever worked with Webflux or Mono in a Spring Reactor, but for classic programmer which know Java, it could be a bit strange to work like this because it is a functional way of working. So under the virtual threads, it was the fix to this situation, to this non-trivial way of working with threads and to scale. And so what we have virtual threads that are instances of java.lang.Thread. So it is still the same, but you have many to many scheduling. This means you have M2N scheduling. This means you have many M virtual threads mapped to fewer N OS threads. So it is lightweight, cheap, and plentiful. I will show you a schema, but remember that the analogy like operating system virtual memory, but for threads. So here's the schema. You have the operating system thread like this that are visualized in the Java virtual machine as carrier threads. So these ones are limited, and here you have a queue of virtual threads that are nearly illimited. You can have 1 million of virtual threads. So you see, this one are the physical threads, and then they can switch between a million of virtual threads. So this is the way to scale with the virtual threads. So the goal is to keep the thread per request model. So you still work with threads. You have near optimal hardware utilization. It is really efficient and optimized. It is compatible with existing code. So you have nothing to change. Thread local, debugging, profiling. Your old code will still working, and no new programming model to learn. So you don't have to learn such things like reactive programming to use framework like Reactor, etc. You use only your way of working with Java as you do in your daily coding. And here an example of use of virtual thread. So you have an executor, but to have a virtual thread, you invoke the method new virtual thread per task executor. I think for the other way, you have another method which is an executor also, but here it is the one which is named virtual thread. So you have this little code which is a stream, and then you do for each, and then you execute and you do a sleep of 1 second, and then you return the value of the instance, so the integer. So with that, you can have 10,000 concurrent tasks, which run very fine and no issue. I told you just before, you can run 1 million virtual threads easily. I don't know if you know the 1 billion threads that have been done by several Java developers in the past by Gunnar Morling, a Java champion, and they show that you can use a million of virtual threads at the same time. But with normal OS thread, it will likely crash. So when to use it, it is best for high concurrency, input-output bound tasks, HTTP calls, DB queries, etc. It is not faster than platform threads. They give scale but not speed. It is not quicker. It is just that you can do more than you used to do. And you don't have to pull virtual threads. You create one per task. So one activity, one thread, and you can do that with all your activity, all your tasks. And so you don't have to share by task. You just create one virtual thread by task. So for observability, virtual threads are fully supported by tooling, Debugger, Profiler, Java Flight Record, new thread dumps group by task, and JSON export by GCMD. So you will see your friends of ops teams will have what is necessary to do the observability of this kind of virtual thread. And then there was also a pinning issue. So to get straight on it, you have a synchronized block, which were and native codes, which were problematic for virtual thread, which were block which are stuck with a carrier thread. So this thing has been fixed in Java 24. So now there is no more pinning, because pinning means that there was a kind of bottleneck which was still not resolved in before Java 24, but now it is fully mature, and you can see in 2023 you avoid synchronized use logs, and in 2025 you use the best tool for the job. So you can use the synchronize or the fix that you had to use relentless log and based on semantics, so not pinning fields. So the key takeaways to conclude is that virtual threads are simple, scalable, concurrency, ideal for server apps, fair per request style preserved, tooling ready, debugging, Java Flight Record, thread dumps. The pinning issue for synchronized and native calls are solved in Java 24, and now in Java 25, the virtual threads are mature and production ready. Thank you very much. See you soon.